Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in the moon hopping series that I'm doing here, where we're going to go from the moon, from all the moons of Jupiter. We're going to start off on Callisto, then sort of hop down to Ganymede, then from there hop down to Europa, and then from there to Io, and that'll complete the series. We're spending a lot of time on the first part of the hop, on the Callisto to Ganymede hop, so that I can really explain everything in a lot of detail. That way, if you want to follow along, you should hopefully have all the information that you need to duplicate this flight, not only for the moons of Jupiter, and you should also be able to go to any direction, and you should be able to go from any moon to any other moon. We just happen to be going through them in order, but you don't have to. You could go from Callisto all the way down to Io, and this plan should work just fine. And you should also be able to do this on any of the other moons of any other planets. And it's also worth pointing out that this particular method should also be valid for going from any planet to any other planet. Because if you think of Jupiter as being the star, and the moons of Jupiter around Jupiter as being planets, basically then all we're doing is going from one planet to another planet, and we're using IMFD to do that. Now let me go ahead and switch camera views here and pick up kind of where we left off. Now this video is a little bit, sequentially for me, is a little bit off because I've actually started to record this part 3 times. This is actually, I think, the 4th time. Ran into a couple of technical problems, and in one case I just simply forgot to switch my camera views, and I looked up 5 minutes later, realized that I still had this view up, so I started over. Anyway, let's pick up where we left off. In the last part, we lifted up off of Callisto, and we got into orbit around Callisto. At least we got up to orbital velocity. We haven't circularized our orbit yet. So the next step then is to set up our plan for actually going over to Ganymede. Now, one question that comes up quickly is, do we need to circularize our orbit or not? That will depend on when we reach the ejection point. We've kind of talked about this a lot in a lot of other flights, but in case you're not familiar with the idea, when we look at orbit eject here, we can see that our apoapsis is over here. It's that point over here. We can also look at that in orbit MFD. If we bring up orbit MFD, change the projection to the ship, we can see that this is where we are at, and our apoapsis is over here. But if we look at orbit eject, we can see that the eject point is here. So we should reach the eject point long before we reach the time to the apoapsis. So in theory, we don't need to circularize. But you'll also note that the TEJ given to us in orbit eject is 9,300 seconds. And I can assure you, and we can even see that here in the time, the orbital period of one orbit of Callisto is 8,000 seconds. So obviously, according to the orbit eject, it wants us to go all the way around one time, plus an additional, whatever that is, in order to reach the eject point. Now, maybe we'll have to do that or maybe not, but just keep in mind that if we do go all the way around, we're going to have to circularize when we get to that point. If we can set this up quickly enough and just do the burn here, then we're going to reach the eject point before apoapsis, and we don't have to worry about circularizing. So that's just something to keep in mind. Now let me bring interplanetary back up on this side so we can see target intercept. Now, bearing in mind the apoapsis stuff, let's take a look at our notes. And I've transferred the notes over to my Google Drive already. And like I said, I started to record this part 3 times. So I've already got notes for... okay, so this here was from video 1, notes from video 1, and these are the notes from video 2, and now this is where we're at. And since I've already started this 3 times, I've already got a substantial set of notes here, and I'm not going to throw them away. So what we want to do for step 1 of this 3rd part of the video is we want to load the orbit eject program on the opposite side, and that's where we currently have the target intercept program loaded. So in other words, we have target intercept on this side, you can see it, and we want to replace it with orbit eject. So we're going to press menu and bring up orbit eject. Now, the reason we do that, and the reason we don't just keep orbit eject over here, is because when you have IMFD shared, it pulls its data from the side that it's shared from. So this side is shared from this side. So that means that this instance of IMFD basically doesn't have any of its own data. It's getting all of its data from this side. So if I were to leave the orbit eject program over here, I would lose all the data. I would lose all the orbit eject data. So in order to prevent that from happening, I'm going to first load orbit eject over here. So you can now see that I have orbit eject on both sides, but on this side it's not shared, and on this side it is shared. So I've got that in the notes. So now we have orbit eject on both sides. Now on the side where we originally had the orbit eject program, and maybe I should make that a separate step. I've since also turned this into a numbered list so I don't have to renumber these each time. Now on the side where we originally had the orbit eject program, press menu and then unshare that side. So this is where we originally had orbit eject, so we're going to go menu and page and then unshare. And notice when we do that, we don't lose our data from orbit eject. And if we did it really any other way, then what you would see happen as soon as you change things around, wherever you had orbit eject at, you would suddenly lose all your data. And this is the only way to prevent that from happening. Okay, so now the next thing we want to do, here again, if we see that the orbit eject point is after apoapsis, then go to the apoapsis and circularize our orbit. We kind of talked about that a little bit already. And in this case, our eject point is here, so we, in theory, we don't have to circularize. Again, I'm not sure why orbit eject says that the TEJ is in 9,000 seconds. Maybe we can do an adjustment on that now. Let me find out. Let's go to here, and this is only going to be 400 seconds or something from now. So let's set it to 0. And now let's go and just put this adjustment at 10. And what we're going to do is we're going to bump that blue line over to that point. Actually, we're going to bump the blue line around until the DV is at its lowest. So just do adjustments as necessary, but it's just going to be 10 or 100. And the DV is at its lowest point right here. So 1012 is at its lowest. Just continue adjusting that. Yeah, 1012. So let me just go back to that point. And you can see we're coming up here not too far away. So I'm going to continually bring the time warp down to 0.1 and or pause. But let me make that a step. Let me make that a note, because if for some reason you come up into orbit and see that the TEJ has been put way out into the future, 1 or 2 orbits out, then you're going to want to reset that. So let's make that a step. But this doesn't change. It doesn't change the fact that if apoapsis was here, we would have to do that first. Because sometimes what will happen is you'll get up into orbit and you're going to be like way back here. You'll be on the other side from the eject point, and then you're going to reach apoapsis there, and you'll need to circularize long before. So that part doesn't change. But let's add another step here. If the TEJ is more than 1 orbit from the time to eject, start by setting the TEJ to 0, and then adjust the time, and then adjust the TEJ forward until the blue line, I think it is. Yeah, until the blue line is at the eject point. But more importantly, adjust the TEJ until the DV is as low as it will get. Let's word it that way. And while adjusting the TEJ, you may want to start by having it at a 10x adjustment instead of 1x. That's a good way to put it. So again, when we started here, for some reason, it went from 9,000 seconds to, or rather it went from, because you noticed if you go back and look at the video when we first got into orbit, it said the TEJ was 500 or 600 seconds out, but at some point in our orbit it changed suddenly to 9,000, and I have no idea why that happened. And that would be fine. We could do that. we could say, well, we're just going to keep that figure of 9,000, whatever it was. So we're going to pass the eject point. We're going to go all the way around to apoapsis, circularize, and then go around. But I just don't see any reason to do that since the eject point's right there. Okay, so once that's done, then the next step that I put in my notes here already is go to the side that we unshared, which was over here. So maybe I should, since we now have a new step in here, instead of saying that we just unshared. So go to the side that you previously unshared from step 2. Yep. So go to the side that we unshared, referring back here to this step, and then go to the course program and load the delta velocity program on that side. So on this side, we want to go to course. Actually, I gotta unpause. Course, and in order to get to the delta velocity program, we first have to go back to the menu, and we get back to the menu from here. You can see it says target intercept. We'll just hit plus. Now we've got our menu, so we'll go next, next, next. Set. Now we've got the delta velocity program loaded. And from here, we can target. Actually, I got to think about this for a second. We have to set our source as our vessel, and this is actually one of the reasons I had to stop recording and re-recording once, because I forgot to do this step, and it ended up messing me up really bad. So we need to set the source as our vessel, and the easiest way to do that is just by pressing X. And you'll notice now it says that the sources and references are possibly invalid. So now we need to reference Callisto, I want to say. And target Ganymede. Actually, I'm not doing that right. Let me check on that for 1 second, because now we've got the source as Callisto. So let me think about that again. Source is us, and the reference is Callisto. That's how we do it. Okay. Target, it was wrong. So, okay, let's do that again. So the source is us, which is just X. And then the reference is Callisto. Then we can press PRJ to change our projection from whatever it was to self. So let's put that in the notes, because that's where I went wrong prior. So go to the course program and then load the delta velocity program and press reference to reference the body that you're on, or that you're starting from. Which we've already done, so we've referenced Callisto. Now page over to the other set of options to get to the other page of options and set your source as your vessel. Note, just type X and hit enter. And then optionally press PRJ to change the projection to self. And we've already done that. And the reason, again, you might want to do that is because if you have the projection set to that view, then you kind of get this cockeyed view of your projection. And personally, I don't care for that. Boy, we are so close to the time to do the burn. Well, we haven't finished setting this up yet. So then the next thing, after you've got the sources and the references set up, is to copy the information from orbit eject over to the delta velocity program. And we'll start with the TEJ, and that's just going to be that number. So set, and then whatever you see there, in this case is 401, and enter. Now we need to copy the delta velocity from the orbit eject over to the delta velocity program. But something I want to point out here is that this number that you see, this is the total delta V, and this is not necessarily prograde. This could be all plane change. It could be all inward or outward. In most cases, it's going to be some combination of prograde, inward, and plane change. And what you may also have is this may not be all positive prograde. It might be negative 200 prograde plus positive 300 plane change plus positive 500 inward outward. You don't know. That's the point. So what you have to do to find out is you have to go to the other page of options and then bring up the burn vector. So let me pause here and just check the notes. So like I say here, copy the eject plan over to the delta velocity program. Note that the en route DV is not necessarily all prograde. When I've already, again, I've already got that mentioned because in the notes, because I've already done this once. So what I'm talking about the en route DV is here, where it says en route delta V. Note that number is not necessarily all prograde. So press the page button and then BV to see the DV breakdown. So page, which we've already done, and BV, and we can see the breakdown. And again, the only reason I'm constantly pausing is because we're so close to the time to burn and I don't want to miss it. So if the DVP, that's the plane change, and DVI, actually I should say really if any of these are very low, but specifically if the DVP and DVI are very low, you can just put in all the DV as DVF, which is forward or prograde. So if we look here, we can see that according to the breakdown, our forward, which is prograde, is 1011, and our DVP is like nothing. It's not even worth commenting on. And then we've got a 23 meter per second DVI. Even with that amount of DVI, we could, that's inward, outward. Even with that amount of DVI, we could really probably still just put it all in as prograde. But to do this, to copy from the orbit eject program over to here, what you would do otherwise would be to go to DVF and just set it to that number, paying close attention to if this is negative or positive. Notice that there's no negative sign in front of that, so we just want to type it in as we see it. In this case, it's just 1011. You can either put in 0.9 or just put it on, or just write it as 1012. For the DVP, this is nothing. There's no point in putting it in, but if it was a significant number, note that there's a negative in front of it, and you would put it in as negative. And then finally, the inward-outward, you can see it's 23. We'll go ahead and put it in, although I don't even think it's necessary. But now we've got all the data copied from the orbit eject program into the delta velocity program. Now we want to see how this would carry out if we performed this burn as is. Something else I'll mention, I really wanted to say this earlier, but I completely forgot. Before you ever set up the delta velocity program, if you want, you can shortcut this extra step that we're doing by just pressing page, pressing page to bring up this second page of options. And you can actually auto burn the orbit eject program just as it is. You don't have to set up the delta velocity program like we're doing here. So this whole idea of, bringing up orbit eject on the other side and bringing up delta velocity, you can actually shortcut all of that, skip it, and just go straight to auto burn. The problem with doing that is that the orbit eject solution is not as good as it will be if we do this extra step. I actually tested this once right before recording, and if we do this burn in orbit eject as is without going over to the delta velocity program, we'll get to Ganymede with no problem, but the orbit eject program overburns by about 26 meters per second, so it's a little bit wasteful. But even there, you could actually just do the burn and then watch it in map IMFD and just stop the burn early, stop it 26 meters per second before it got to that point. But this extra step is worth it, and I think it's a good habit to get into doing it, so we're going to do it this way. So we've got the orbit eject plan copied over to the delta velocity program. We're done with orbit eject. Now let's go to our next step. I don't know if I put it in the notes yet or not, so let me check. Yeah, now load IMFD's map program on the side that has the orbit eject program and share it with the delta velocity program. So on this side, where we've got the orbit eject program loaded, we're going to go to menu, and we're going to load the map program, but first we're going to share it. So share to 0. Now bring up the map program. And again, let me check the notes here to see what I've already commented on. Now in the map, in IMFD's map program, press target to target the destination body. Let's do that. It's going to be Ganymede. And then we want to turn off auto zoom, turn on DSP, then page over to the other options, press SOI, and then turn on the plan. This is kind of something that we always do with the map MFD. So auto zoom off, turn on the display lines, page over, turn on the SOI, turn on the plan. Now page back over to this option, and if it's not already selected like it is here, then we want to press the select until we have Ganymede, and I've got all that in the notes. Finally, this last little bit, finally press PG again to get back to the previous page of options, and press select to select the target body as the reference, and in this case the target body is Ganymede. Now we basically kind of do what we always do with IMFD. Hopefully you've seen the training videos that I did with Dimitri, so you kind of know what I'm talking about here. According to map MFD, and this is very accurate, we're going to have a PEA at Ganymede of that number, 18,420. So now we can come over to our delta velocity program, and we can refine the time, the prograde, the plane change, and the DVI to bring this down to the surface, or in a lot of cases we actually want to kind of put it below the surface, like -1000. That way, whichever way it errs when we leave the orbit of Callisto, it won't matter, or at least it'll get closer to the surface and not farther away. So that's the next step. Let me put it in the notes now that we're on track with our notes. 9. Once, let's see, how do I want to word it? Once you have, okay, now adjust the TJ, DVF, DVP, and DVI in the delta velocity program in order to get the PEA as seen in the map program down to the surface. Start by adjusting the TEJ at 1x, and then adjust the DVF at 1x. In most cases, I should say in many cases, you can get the PEA where you want with just the TEJ and DVF. Okay, so let's do that. So we're going to start by adjusting the time, and then we're going to adjust the prograde. Then if necessary, and only if necessary, we'll make adjustments to plane change and DVI, but most likely we'll get it with just time and plane change, or time and prograde. So let's go back to real time, and we're just going to see what works. Bumping time forward, you can see that's helping. It's bringing the PEA down. And again, this may be all we have to do. It looks like it's starting to, I don't know, it's still going down. Now it's going back up. When this happens, you want to maybe go forward by maybe 2 or 3 more clicks. Then go to the prograde and adjust the prograde. And that's going to be the wrong way, so let's go backwards. And adjust it until the PEA won't go any lower. And then do the same thing, kind of overshoot it, let it go back up. It's still going down though. And that's actually nice because it's meaning that we're going to be using even less delta V than we planned. But let's keep going backwards until it won't go any lower, and it's probably going to start going back up about now. No, it's still going down. It's nice. Okay, now it's going back up, but do the same thing. Overshoot it a little bit, maybe go all the way out to a couple more clicks. That might be too much. Then go back to the time and see what happens if we do a time adjustment. Now, if I take out a little bit of time, you can see we are there. We're basically right where we want to be. We're now a little bit below the surface. We know the radius of Ganymede is about 2,000 something, because we saw that earlier in orbit MFD. So if we try to maybe target the center of Ganymede, then we'll have a PEA of about -2,000. So right about there. That's all the adjustment that we need. So in this case, let me pause. We did have enough time to get everything set up and still do the eject right away. We don't have to go all the way around, so we're not having to circularize the orbit. So that's good. We're all done. Let me just go back to the notes real quick and see if there's anything I want to say here. Adjust the TEJ. Let's see, start by adjusting the TEJ. Now, note that when you adjust the time, or I should say adjust the TEJ to find the low point, it will go faster if you overshoot the time by a few seconds and then go adjust your DVF. If you just bring the PEA down to the low point and then go adjust the DVF, it will take longer. It's as simple as that. You can get it that way, but you'll just have to go back and forth a whole lot more than you would if you do this overshooting method. And it's the same thing we do with TransX. Okay, so let's go ahead and carry out the burn now. We've still got a couple minutes left on this video, so let's just go ahead and do the burn. Now to do the burn, we will page over to the other page of options and basically just auto burn. That's all there is to it. So let's go ahead and put it in the notes. Once you have the PEA down to a value that you're happy with, press PEJ, press PG on the delta velocity program to bring up the BV and AB options. Then press AB to carry out the burn. Optionally, you can press BV to view the burn vector page. Okay. So if we view the burn vector page, one thing that we can see here by doing that is we can see where the plus sign's at. That's beneficial if you want to really conserve your delta V. You can adjust the vessel so that that plus is in the center before the autopilot has a chance to do it. And by doing it that way, if you start 200-300 seconds ahead, you can generally get there more efficiently than the autopilot will. That's not going to be important on a flight like this where we have all the fuel that we need. So, but on those DV freak missions that I do, I really like to save fuel wherever I can. Now we're going to do the burn here in just 3 minutes. Let's warp time forward. Once we get really close to the time to do the burn, you can also come over to Map IMFD, I should say the map program, and turn off the plan. So let's put that in the notes. When you are within, say, you can either say after you start the burn or even a few seconds before the burn has started, shut off the plan in the map program in IMFD's map program so that you can see the result of the burn in real time. That's important. So let's go forward till we're just about ready to do the burn. Or even after the burn has started is fine. And then we want to shut off the plan, because you'll see when we turn off the plan, now we're going to see what's going on in real time. And there we have it. We're all set. And again, the benefit of doing it this way is that I can see now that my periapsis is -2000, which is exactly what I want. Whereas if I just did the burn according to the orbit eject program, then what ended up happening when I did it off camera was that it got the burn all the way down to this point, but then it kept burning for another 26 meters per second just due to the inaccuracy of orbit eject. Whereas when I take the extra time to go through the delta velocity program, I have an outcome that's spot on. Now again, though, if we wanted to, we could have used the orbit eject program, and then we could have loaded we could have loaded IMFD's map program up and just watched the burn to see what happened. And then we could have killed it when we saw, well, we are where we need to be. We don't need to burn anymore, and we could have just killed it. But again, I think this extra step is well worthwhile because there are going to be some cases where the plan or the burn that orbit eject gives you isn't going to be sufficient, even if you do watch the burn. Okay, now we're going to head off to Ganymede. So it's a good stopping point right here. Plus, we're at 30 minutes. So let's go ahead and wrap things up. When we come back, we're going to obviously do the transfer from Callisto over to Ganymede, and it looks like it's going to basically be a perfect Raman transfer. And I think it was like a 6-day flight, so it's not going to take very long to get over there at all. So if you like this part of the video, hit the like button. If you didn't like it, hit the don't like button. Subscribe to the channel if you're not already subscribed. Check for links in the description down below, and I will see you in the next part. Find the apoapsis stuff. Let's take a look at our notes. And I've transferred the notes over to my Google Drive already. And like I said, I started to record this part 3 times. So I've already got notes for... okay, so this here was from video 1, notes from video 1. And these are the notes from video 2. And now this is where we're at. And since I've already started this 3 times, I've already got a substantial set of notes here, and I'm not going to throw them away. So what we want to do for step 1 of this third part of the video is we want to load the orbit eject program on the opposite side, and that's where we currently have the target intercept program loaded. So in other words, we have target intercept on this side, you can see it, and we want to replace it with orbit eject. So we're going to press menu and bring up orbit eject. Now the reason we do that, and the reason we don't just keep orbit eject over here around Callisto, at least we got up to orbital velocity, we haven't circularized our orbit yet. So the next step then is to set up our plan for actually going over to Ganymede. Now one question that comes up quickly is, do we need to circularize our orbit or not? That will depend on when we reach the ejection point. We've kind of talked about this a lot in a lot of other flights, but in case you're not familiar with the idea, when we look at orbit eject here, we can see that our apoapsis is over here. It's that point over here. We can also look at that in orbit MFD. If we bring up orbit MFD, change the projection to the ship, we can see that this is where we are at, and our apoapsis is over here. But if we look at orbit eject, we can see that the eject point is here. So we should reach the eject point long before we reach the time to the apoapsis. So in theory, we don't need to circularize. But you'll also note that the TEJ given to us in orbit eject is 9,300 seconds. And I can assure you, and we can even see that here in the time, the orbital period of one orbit of Callisto is 8,000 seconds. So obviously, according to the orbit eject, it wants us to go all the way around one time, plus an additional, whatever that is, in order to reach the eject point. Now, maybe we'll have to do that or maybe not, but just keep in mind that if we do go all the way around, we're going to have to circularize when we get to that point. If we can set this up quickly enough and just do the burn here, then we're going to reach the eject point before apoapsis, and we don't have to worry about circularizing. So that's just something to keep in mind. Now let me bring interplanetary back up on this side so we can see target intercept. Now, bearing in mind the other moons of any other planets, and it's also worth pointing out that this particular method should also be valid for going from any planet to any other planet. Because if you think of Jupiter as being the star, and the moons of Jupiter around Jupiter as being planets, basically then all we're doing is going from one planet to another planet, and we're using IMFD to do that. Now let me go ahead and switch camera views here and pick up kind of where we left off. Now this video is a little bit, sequentially for me, is a little bit off because I've actually started to record this part 3 times. This is actually, I think, the 4th time. Ran into a couple of technical problems, and in one case I just simply forgot to switch my camera views, and I looked up 5 minutes later, realized that I still had this view up, so I started over. Anyway, let's pick up where we left off. In the last part, we lifted up off of Callisto, and we got into orbit around. Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in the moon hopping series that I'm doing here, where we're going to go from the moon, from all the moons of Jupiter. We're going to start off on Callisto, then sort of hop down to Ganymede, then from there hop down to Europa, and then from there to Io, and that'll complete the series. We're spending a lot of time on the first part of the hop on the Callisto to Ganymede hop so that I can really explain everything in a lot of detail. That way, if you want to follow along, you should hopefully have all the information that you need to duplicate this flight, not only for the moons of Jupiter, and you should also be able to go to any direction, and you should be able to go from any moon to any other moon. We just happen to be going through them in order, but you don't have to. You could go from Callisto all the way down to Io, and this plan should work just fine. And you should also be able to do this on any other moon, any other